Graphene, a new nanomaterial of dreams that will change the future. Graphene technology started in 2004 as a technology that separates graphene with a thickness of single atomic layer from graphite. Its significance was recognized by the Nobel Prize in Physics in 2010 with its great potential for next-generation semiconductor electronic devices, heat dissipation materials, transparent electrodes, and displays. The Graphene Research Institute at Sejong University is taking the lead in the field of graphene research with development of graphene nanoelectronic devices, cooperation with overseas organizations, and training of professional researchers. GRI is the first government-funded institute on graphene-related research in Korea that was selected for the Priority Research Center program of the National Research Foundation of Korea in 2010. In 2012, the institute was selected for Nanomaterial Technology Development Program of NRF to develop graphene growth, defect control, and innovative electronic devices. GRI has established the GRITPC International Research Center with the University of Texas at Dallas in 2018 for the development of multifunctional convergence technology for optical materials and devices that combines graphene and LED technologies. In 2021, the institute was selected as Basic Research Laboratory for Janus 2D Semiconductors and their Valley Spintronics applications, under the BRL program of NRF, to investigate Janus 2D materials. With the exfoliation technique of graphene using Scotch tape developed in 2004, graphene was not easy to obtain due to its small size and different shapes and positions. The chemical vapor deposition method developed later made it possible to produce graphene with large scale and excellent quality, but the graphene growth speed was slow. The roll-to-roll CVD method, which compensates for this limitation, enables continuous synthesis of graphene, but has the disadvantage in that the quality of synthesized graphene is not good. GRI at Sejong University has developed a conveyor CVD equipment and rapid synthesis recipe to secure the technology with both productivity and quality of CVD graphene, and has completed patent application and registration. GRI is conducting research on various 2D materials beyond graphene. Although graphene has excellent electrical properties such as high carrier mobility, the off-state current caused by the absence of a band gap has made its application to low-power integrated devices less feasible. GRI is conducting research on the physical properties and the utilization of 2D materials, such as hexagonal boron nitride and transition metal chalcogenides, which have a band gap that can compensate for the limitations of graphene. GRI has implemented deformable and transferable optoelectronics with remote epitaxy methods. The LED device was fabricated based on gallium nitride. Micrometer-sized LEDs were grown on the graphene surface by remote epitaxy, and their exfoliation made it possible to transfer the LEDs to an arbitrary substrate and to manufacture flexible light-emitting panels. LED panels, prepared through remote epitaxy, could be bent or folded. GRI is developing a heterostructure that vertically stacks different 2D materials, like Lego blocks using van der Waals interactions. Such vertical stacking makes it possible to obtain various materials with desirable properties. GRI at Sejong University, conducting world-class research on 2D materials, is preparing for a new future through the establishment of GRITPC International Research Center with University of Texas at Dallas, which has been conducting research based on photonics and optoelectronics such as photonic crystals and perovskites. Since its establishment in 2018, the GRITPC International Research Center has been continuously holding workshops for active research exchanges. GRITPC International Research Center has focused on the design of photonics nanomaterials and the growth and synthesis of low-dimensional materials and development of photonics and optoelectronic devices based on these materials, which ensures that the center is recognized for its world-class achievements.
세종대학교 그래핀 연구소는 국내 여러 기관과의 연구 협력을 통해 2차 물질 연구의 구심점 역할을 하는 동시에 세계적인 연구 성과를 내기 위해 부단히 노력하고 있습니다. 많은 관심과 성원 부탁드립니다.